Hello students, welcome to our online open class. Today we will learn about the fifth process of program design for cavity type parts. It's about the finished machining of the internal contour bottom surface. To ensure that the bottom surface of the part is not damaged in the operation, the side surfaces should be machined first, followed by the bottom surface. For this process, we have adopted the UG automatic programming for fixed contour milling method. Most importantly, we should select the inner contour bottom plane as the boundary. The cutting method used in the tool path consists of a non-steep cutting mode that follows the periphery, and the strategy is set down to milling and automatic. And we should choose an appropriate reciprocating deep processing. The programming steps are as follows. First, create an operation. This process uses the fixed contour milling method, specify the cutting area, set the driving method, set the tool path. Second, generate the tool path and tool path simulation. Please refer to the skill operation for detailed operation specifics. Let's begin the skill operation demonstration for the internal contour bottom surface fine machining procedure. First, select Geometry, right-click to find Insert, then choose Procedure, and select Fixed Contour Milling. Choose an 8 mm diameter end mill. Choose the fine machining method and select Geometry B. Name the process Internal Contour Bottom Surface Fine Machining Procedure and click OK. Pick the cutting area, selecting the bottom surface and then click OK. For the driving method, choose Area Milling. Selecting following perimeter, set the maximum distance to constant with a step distance of 0.2 mm. Then choose the reciprocal depth machining method, setting the depth cutting layer to constant with a step distance of 0 mm and click OK. Modify the parameters, setting the spindle speed of the 8 mm diameter tool to 3000 and the feed rate to 800. Then click Calculate and click OK. Generate the tool path and then click OK. Next, select the procedure. Right-click to find the tool path and then OK. Adjust the animation speed to 2 and click Play. In fixed contour milling, the thickness can be observed through color display to check if workpiece is within the tolerance range. The tool passes generated for multiple layers in fixed contour milling for removing the workpiece excess material involve two-axis coordination. When fine machining island type cavity parts, the bottom surface is machined first, followed by the side surfaces. NC stands for numerical control. Once the tool path operation is complete, click OK. Right-click to access post-processing and select the corresponding post-processing file. Set it to metric or imperial. Click OK and then OK again to override the original file. The machining program is now generated. Modify and optimize the program as needed for your equipment. The skill operation is now complete. Third, review the machining process list. Fourth, check for overcutting and the residual thickness. Fifth, generate the post-processing file. In today's class, we completed the fifth process of cavity part program designed on the UG software platform. During the programming process, we used the fixed contour milling method. You can practice on your own following the operation demonstration. Correctly choose the inner contour bottom plane as the boundary. The finished machining allowance is set to 0 by default. Now, assuming that you are technicians, you should set appropriate parameters and optimize them in the program. Thank you for listening.